The big question is, what are blueprints and how will they make my life easier? Well, blueprints are a visual scripting tool available in Unreal Game Engine. Let's break it down. Unreal Game Engine is a software that you can download that allows you to make games. Think of it like a workshop where you can assemble its various parts and put it together to create a complete game. In fact, Unreal is the most used game engine in games today, with many AAA game studios using it. And if they're not, it's almost always an engine based off of Unreal. So chances are you're likely to run into it during your game development journey. Now that we know that, what is a visual scripting tool? In game dev, the big bad that everyone always fears is coding. Computers can only understand very precise instructions. Coding languages are the vehicle with which we communicate with the computer. Problem being, it's not as forgiving as a language like English. The first thing to do when making a new blueprint is decide your class. Blueprints come in many different classes or types, and some of the most common ones are actors, pawns, and characters. To summarize, an actor is simply an object that you want to do a function or task. Pawns are actors that players can control. Think of something like a movable box. And the character is, well, a character the player can control and walk around with, derived from the pawn class. So when choosing, ask yourself, is the object I'm making a character to control, an object to be controlled, or something else entirely? After deciding upon a class, you'll need to know what functions and what variables to add to that blueprint. A function is just what task you need that object to do. Take a door, for example. What would you need it to do? That's right, open and close. Even something as simple as that is a function. Now variables are simply the information needed for that function. In our door example, that's like knowing who opened the door and what side of the door they're on. After putting all that information together, we've gone past the hard part. Now, we simply put it all together in the blueprint interface. In the blueprint interface, you can create connections between your functions, creating a nice flowchart of what happens. This is the logic of our object. The start of all of this is an event. Think of an event like an action that has happened in-game, like a person presses this button or goes into some area. This event, as you can see, has a white arrow on it. This white arrow can connect to your functions. Basically, it tells the object to start the task when this event happens. Easy, right? Just click and drag, and we've created an object that can be interacted with. You can see how these tasks can chain together to create more complicated behaviors as you need. To give you an example of blueprints in action, let's make a door. Something quick and easy. First, we need to create a new project in Unreal. So after opening up Unreal Engine, let's click on New Project in the upper left corner. Then, we're going to use the first person template today. This gives us a pre-made scene and a player to control and mess around with. To the right, you'll find a description of the first person template and some properties. To be exact, make sure you have the target platform set to desktop and the variant set to arena shooter. Also, ensure that blueprint is highlighted here in the project default, as that's obviously what we're trying to do here today. You can name it whatever you want and then click create. Since I already have an example created, I'm just going to go ahead and open that. Now that we have our project open, the first thing to do when creating a new blueprint is to open up the content drawer. In this, there are two ways of adding a blueprint. Either clicking the add button and then selecting it, or simply by right-clicking and then selecting it. When we click, a window will appear showing all the types of blueprint classes. You can see here all the types we described: actor, pawn, and character, as well as others you can read about on your own time. For our purposes today, we'll choose the actor. When you do that, it'll have a text box and it'll allow you to rename it. For our purposes today, we're going to call it door example. When you're done naming it, you simply double click it to open up the outliner. Once you're in the outliner, you'll see a whole bunch of items and words. The main gist of it is on the right here are the different properties of whatever object you have selected. Meanwhile, on the left here, you can see your hierarchy and all of the objects within your new blueprint, as well as functions and variables, among other things. On the top here, you'll see the tabs open. The most notable ones we have here are the viewport, which you can see right here, and the event graph. Go ahead and close the construction script tab, as it's not important right now, and click on the event graph tab. Here, you'll see three nodes. The top one here is event begin play. That activates when you hit play. so at the beginning of your game. It just runs once and never again, so it's useful for one-time setups. The next is actor begin overlap. This triggers when other objects, say, like our character, overlap with the blueprint. Say we place our blueprint within the game and a character walks into it. Then the code would trigger. Finally, there's the tick event. This activates every frame, so if you're at 60 frames per second, then 60 times a second. It's useful when you need constant updates to something, like say a clock that needs updates every second. In this tutorial, however, we only need the overlap event for when a character walks into our door, so we can open it. Clicking back onto the viewport tab, we'll go to the top left, where it says components. And under that, we'll click add, so we have some visuals for our blueprint. You can add basically anything here, so let's just go with a cube for simplicity. So you go add and cube. As you can see, it's here in the viewport, and I'm going to scale it so it's a bit more door-like. Just a basic square like that. Now, if you go back to the Unreal Scene view and open up the content drawer, you'll see that the icon has changed to our cube. Now we can drag it anywhere onto our scene. To actually make that cube do anything though, we need to head back into the blueprint editor. We already have an event that can activate our code if the player overlaps. No way to really tell when that happens. This is where colliders come in. Colliders define an area that actually make our blueprint take up space. Because right now, the blueprint is basically one big hologram that's all visual and not really doing anything. So just like how we added a cube, we're going back to the add button and we're going to type in box collision. This collider, like the name suggests, is in the form of a box. And after adding it, you can see the outline of a cube around our original cube. You can use the scale and move tools to adjust it to be a better fit around the original cube. You're going to want it to be approximately where the player would be, so you want it to be a bit bigger than the cube itself. The default position is good. Now, whenever our player walks within that cube, the door will detect them and the event will activate our code inside it. It's important to make sure the box collider is not a child of the cube object. If we do this, our collider will move alongside our cube, which will mess up some of the detection of our collision. Before we go ahead and start making functions for that, we're going to select the box collider and scroll all the way down on the detail panels on the right. We're going to find the section that says events, and we're going to find the one that says on component begin overlap and hit the plus button. This will add a new node to our event graph. This new node is functionally the same as the other overlap event, but this one is tied to the box collider, which makes things easier. There are a lot of pins on the node that give extra information on what is overlapped and how, but the main one we're using is the white arrow called the execution pin. This pin is what actually activates the code. The first thing we need to do is define what two components that, when they overlap, will cause the code's functionality. In this case, it's the box, which is already defined in the initial event, and the player, which we need to add a cast to. This cast essentially is just detecting what is overlapping with the box. We're going to click on the execution pin and drag off. This will create a new window that will ask you what function you want. And we're going to search for cast2 BP underscore first person character. Next, we want to connect the character with the other actor pin on our initial event. This indicates that when these two overlap, trigger the event. From the cast area, we want to take the execute pin and find set relative location. And make sure you select it for the cube, which is our door itself, and not the box, which is our collision. Selecting it gives us another node, this time with a blue top, which shows that's a function that will do something. It may be hard at first to know what node or function you should use, but you'll eventually gain experience in knowing either by reading the documentation or by watching other tutorials and understanding what they do. To actually move our door, we need to set its offset Z value to move it. To test this, you can go back to the viewport, click on the move tool on the cube to see. Click on this blue arrow here and you'll see on the right the Z value changing, which is up and down. So back on our blueprint editor, we'll set the new location to 00250. Then we'll click compile up in the top left. Compiling is very important. It's a lot like saving your work, because if you don't do it, the changes will not apply. However, it's not the same as saving, so make sure whenever you make a big change, you both compile and save. If we go back to our scene view and we hit play, you'll see that when we get close to the door, it'll teleport. However, it teleports instead of moving like we want it to, so let's change that. Now, back in our event graph, we want to add a timeline. A timeline allows for time-based animation and can be utilized to add a moving effect to our door. Firstly, we want to right-click and search timeline. Then click add timeline. You can name it whatever you want, but for now, I'm just going to keep it as the default timeline. Next, what we want to do is double-click on it, which will open a new tab, and then click plus on the track button and add a float track. The track is actually what dictates the timing. For our example, we'll have a node at 0 seconds with a value of 0 and another one at 1 second with a value of 1. To do this, shift click at 0 and then change the value here, and do another shift click to add another node with a time 1 and a value of 1. And return to the event graph. Next, we want to right click and add a multiply function. This will essentially control the number of our position. So you see here it's 250. This multiply function will be 250 as well. When we drag it here, we can change this value to 250. Finally, we want to disconnect our original connections, which we can do by right-clicking and clicking break this link. Then we want to connect everything together. So we want to do the cast to the timeline, and then the update execution to the set relative location. And then finally, we want to go to the new location on set relative location and click split structure pin. This will split the pins between your X, Y, and Z values, and then place your multiply functions pin in the new location Z pin. And then when you're done with all that, make sure you hit compile and save. Now, when we go back to the scene view and we click play, it'll move up instead of teleporting up. Back in our event graph view, we notice that it doesn't go down when we leave the area, which can also be something that's fixed. In our blueprint editor, we're going to go to the viewport and select the box. Scroll down on the right on details until you find on component end overlap. This means that it'll trigger when something leaves the box collider. This is very similar to the original one here, so we can actually just copy this cast as well, as we still need to cast to the player. So we want to do the same thing as on component begin overlap. Drag the execution pin to this pin here, and the other actor to the object. Then, all we need to do is simply slot it in to the reverse slot on the timeline. If we go back, make sure to compile and save, we go back to our scene view, we click play. Now we'll see, when we walk up to the door, it will go up, and when we leave, it'll fall. Good work on making that door. You've seen firsthand how we can utilize blueprints to create functionality within your game. So, do blueprints replace code? Not necessarily. While blueprints are an extremely versatile tool and can help add functionality to your game, coding, particularly C++, which is Unreal's native coding language, is much more performant. That being said, while maybe not as refined as C++, blueprints have an incredible advantage: time. It takes a fraction of the time to create, iterate, prototype, and ideate in Blueprint than it does in C++, where most of your time could be committed to bug fixing. So while blueprints are much easier on the human, C++ coding takes less toll on your computer. So it's up for you to decide, is it better to use blueprints or use C++, or a combination of the both? Thank you.